Okay, so welcome back to lecture once again, guys. Now, in this lecture, I'll be talking about a convolutional neural network. Now, convolutional neural network is basically a building block for any algorithm that you are going to study inside a computer vision. So, wherever we are going to deal with images or a video, obviously you need an understanding about a convolutional neural network. Wherever you are going to study an algorithm which falls under a classification, object detection, or maybe a segmentation, again you need this convolutional neural network. Like I said, it's a building block because in a computer vision section, so you will be dealing with an images or maybe a video. Videos are nothing but a frame by frame set of the image itself. Okay, so let me share my screen and let me start talking about something. So for example, if this is an image that I have, right? This is the image that I have. So now if I'm going to hover my mouse, I have just opened up my image in a paint. And if I'm going to hover my mouse on this particular image on my left hand side down corner, right? So I won't be able to hover here. So once I'm hovering, then only you will be able to see a value. So here you will be able to find out a location of a pixels. So when I say that there is a image, right? So when I say there is a image, so it's nothing but it's a combination. It's a combination of a pixels, and then only you are able to see something in a proper shape which you will be able to identify, which you will be able to recognize. So images are nothing but a combination of pixels, and you all will be able to see basically pixel location, by the way, not a value, a pixel location. So once you are going to hover your mouse, plus you will be able to see even a image dimension. So the dimension of this image is what? It's a 1920 cross 1080 pixels, right? So these many pixels, when we are going to combine width wise and height wise, so basically 1920 is a width and 1080 is a height. You can try to click on images and then you can try to check its property. So once you are going to check its property, once you will come inside the detail section, you will be able to find out that 1920 is basically a width of the images, and then height of the images are basically 1080. Now these many pixels, when you will be able to combine, right? So these many pixels means these many, this kind of a matrices, when you are going to combine, then only you will be able to see such kind of images, right? And obviously every pixel will be having its own value. Now when we say, or when we talk about this colorful images, so inside a colorful images, you will be able to find out majorly 3 channels. In terms of a grayscale or in terms of black and white, you will not be able to find out a 3 channel, but yeah, so in case of a colorful images, you will be able to find out a 3 channel. Now to explain you that, so I have a CNN explainer from apolloclub.github.io. It's one of the famous website or blog you will be able to find out, where in an animated way you will be able to see each and everything. For example, so here I have selected a colorful images of a espresso. Yeah, it's a cup, right? Inside that we have a coffee. That's completely fine. Now, so whenever we talk about this image, so you can try to divide this image channel wise into a 3 different channels. So one channel will be having a red channel, another channel will be having a green channel, and another channel will be having a blue channel. So whenever system will try to learn something from this images, some sort of a pattern from this particular images, so obviously it has to divide. If it is a colorful one, if it is a black and white one, or single channel if we have, in that case there is no issue at all. But yeah, so if we have a colorful images, so we used to divide those images into a 3 separate part: red, green and blue. And if you remember, so in my previous section, so I have already talked about it even programmatically, and I have shown you that yes, this is the colorful image and this is the different kind of a channel, and you will be able to separate it. We are going to do that as well, and I have already done that in my previous lecture. So if you have not gone through that, so please try to go through a previous lecture and then try to join this particular lecture. Now here, so as you can see that we have a 3 different kind of a channel: a red channel, green channel and a blue channel. And if you are going to combine it, you will be able to find out this colorful image. Now what is our task, right? What is our task? That's a major question. So our task is very simple over here. So our task is to learn what? So our task is to learn a pattern inside a image. If I'm going to show you this image, or whether it's an image of a cup or maybe some other image, if I'm going to select, right, from this one, so any other images if I'm going to select, so in every images you will be able to find out a shape. right? You will be able to find out some sort of a object. And if obviously all of this object will be having its own shape, right? And that's the reason, so we say that we as a human, we used to say that, okay, so it's an image of a human being, it's an image of like a person called as Sudhanshu Kumar, it's an image of a cup, it's an image of maybe a beer over here, it's an image of maybe a bus over here, it's an image of maybe a pizza, right? So once all these pixels will be combined in a particular shape, then only it will be able to find out, or you will be able to find out some sort of a recognizable pattern inside the images. Now, so we have to teach this particular pattern. We have to teach this particular pattern to a machine that, okay, learn this pattern, learn all of this shape or curve or pixel combination, maybe a color, maybe some sort of a spot inside the images, maybe some sort of a teeny tiny object inside the images, learn a line over there. And if machine will be able to learn, right? If machine will be able to learn, so obviously machine will be able to identify it, machine will be able to recognize it, just like we as a human being can recognize any kind of a object in any of the images. And this is where this entire convolutional neural network comes into a picture. Now, from our past experience, we already know that to train a machine, right? To train a machine, we need a data, right? We need a data, and a kind of a data which should be able to form some sort of a pattern. Then only we can try to provide our X value and we can try to provide our Y value. It is going to perform some sort of a learning operation. Learning means, so it is going to train some of the parameter based on the pattern that we have observed inside a data. It will try to get some sort of a losses, and according to the losses, it will try to optimize itself. And that's a fundamental philosophy of any kind of a learning, right? Wherever we talk about a machine in terms of a learning, that's a fundamental philosophy. Now here we have our images, and we know that inside image is nothing but it's a combination of a pixels, by the way, and obviously layers. If we have like a colorful images, then there will be a layer 1, layer 2, layer 3, or maybe 0, 1, 2, something like that. There will be a layers. Now, so my first objective should be to extract, right? My first objective should be to extract information, or maybe extract some sort of a data in such a way, right? Extract some sort of a data in such a way that it will be able to evolve itself. It will be able to recognize some of the pattern, maybe some sort of a like a filter, some sort of a observation we can try to apply over here, so which will be able to identify some of the things, maybe a line, maybe some sort of a spot, maybe some sort of a color combination, something like that, right? And this is where the convolution part comes into a picture. Now, what convolution does, right? What convolution does? So step by step, it will try to hover over the image, as you are able to see in this particular animation, right? In a step by step manner, it is going to hover over the images. And then, right? So once it is going to hover over the images, it will be able to filter out some of the information. So as you can see that we are trying to apply some sort of a kernel over here. And when I'm going to hover over this kernel, you will be able to find out even a kernel value. It's a very small, so maybe you can try to experience it. Anyhow, I'm going to show you with respect to calculation. Yeah, so don't worry about that. So here we are trying to apply some sort of a filter on top of the images, a learnable parameter, you can say, in other word, and maybe it looks confusing initially, but as we will progress inside this lecture, the fundamentals will be pretty much clear to all of you. So we are going to apply some sort of a filter on top of the images, and then from this particular image, every kernel will try to filter out something. So you can see that from this image it is trying to filter out something, then from this image it is trying to filter out something, from this image it is again trying to filter out something, right? Now this is called as convolution. This is called as what? This is called as basically a convolution. And convolution simply means that try to extract a feature out of the images as much as possible, right? As much as possible, try to extract a feature out of the images. Now, I'll not waste much of your time because I think I have already set the context over here. So quickly, I will get into my slide and I'll start doing a mathematical calculation, because this is a place you will be able to understand things in a better way. So let's start doing a calculation by taking a small image, or you can say a combination of a pixels, and then in a step-by-step manner we are going to perform all sort of a calculation. So here, like I said, that images are nothing but a combination of a pixels. Now, so in general, so let me write it down over here, CNN, right? So convolution neural network. Yeah. So like I said, that images are nothing but it is going to be a combination of a pixels. But before that, so if I'm going to talk about a colorful images, so colorful images will be having, let me, yeah. So colorful images will be having a 3 channels, right? Colorful images will be having a 3 channels, by the way. I think this diagram is not very, okay. Yeah. So now as you can see that we have a 3 layers. I can try to identify that as a layer number 0 maybe. There is a layer number 1 and there is a layer number 2. Now, first of all, what it is going to perform in terms of a colorful images, it is going to separate all of these layers. It is going to basically separate all of these layers. So maybe we have a layer number 1, layer number 0, layer number 1 and layer number 2. Now what it is going to perform, so on each and every layer, because if we have some sort of image over here, if we have some sort of object over here, right, if we have some sort of object over here, so any image or any object is nothing but it's a combination of the pixels, or maybe there will be a line pattern, there will be some dot kind of a pattern, there will be a spot pattern, there will be a multiple color combination over here, there will be a multiple sets over here inside the images. Now, what is my objective? My objective is to learn all of these parameters. So whatever parameter that we have, whatever like a things which is going to give me an identification about the images. So we have to learn each and everything, right? Layer by layer, layer by layer. So we have to basically learn. We have to learn all the edges. We have to learn all the objects apart. We have to learn all the shapes. We have to learn all the gradients inside the images. Now to learn all of those things, I have to extract those information in some way, and then eventually I'll try to learn it. So how I will be able to extract all of this information, and this is where this convolution comes into a picture. So I'll be talking about a convolution first. I'll try to show you the calculation with respect to a small matrices, and then you will be able to understand it automatically. So what we do, so we try to apply a small filter on top of the images. Now this small filter that we are going to apply, let's suppose I'm calling that as a F over here. So filter over here. So small filter I'm going to apply on top of this images. Now this filter will go through this entire images, right? This will go through this entire images horizontally and vertically. Horizontally and vertically, it is going to go through this entire image. It is going to cover this entire image, and it is going to do some sort of a calculation. And eventually it will try to change its value based on the loss that you are going to receive, and then that is called as convolution training, convolution neural network training. So here let's suppose as we all know that images are nothing but a combination of the pixels. So here what I will do, I'll try to consider basically a 5 cross 5 matrices, and I will be assuming that this is representing one of my image. So here 1 2 3 4 5. Okay, then again, so we have 1 2 3 4 5, and inside that I'll try to put some sort of a pixel value. Let's suppose this is my image, right? This is my image, by the way. This is my image. Okay, so here we have a pixels value. Let's suppose we have 1 1 1 0 0. We have 0 1 1 1, again 0. We have 0 0 1 1 1. We have 0 0 1 1 0. We have 0 1 1 0 0. Now this is my original image, let's suppose. Yeah, this is my original image, or one layer of the images I'm talking about, and a small one. I'm not going to talk about like a 1000 cross 1000 kind of a pixels, but yeah, so I'm going to talk about just a 5 cross 5. So this is my image of size what? This is the image of size 5 cross 5. I will try to apply a filter on top of these images. And why I'm going to apply this filter? So that I will be able to extract a feature, right? I will be able to extract the feature. Now you can say that how you can try to extract the feature? No, I'm not going to extract it directly. It is going to learn. It is going to basically learn in a backward propagation that, okay, so this kernel should extract this particular feature. So initially what I will do, I'll try to take a 3 cross 3. I'll try to take a 3 cross 3, a random filter over here. So let's suppose this filter value is 0, 1, 0, minus 1, and then 1, 0, minus 1, and then 1, 0, minus 1. So now this is a filter. This is a filter slash kernel. So we used to say filter, or we used to say even a kernel. Both are basically a same thing, exactly same thing. So we are going to apply a filter on top of this particular image. Yeah, on top of this particular image. And what it is going to give me in a return? So technically it is going to give me some sort of a filter and image pixels multiplication. And eventually I'll try to get a new shape of the image, by the way. So which will be propagated forward. And this filter or kernel which I'm talking about as of now, so this is basically a learnable parameter. So we are going to learn this parameter. So initially I have taken a random value. These values are completely random value. This is not a value which I was aware about, by the way. Yeah, so this is basically a complete random value. So in case of convolutional neural network, we try to train this parameter. For example, in case of a linear regression, right? So we try to write what? So we try to write mx plus c. Now c and m is basically what? It's a trainable parameter. It try to adjust itself based on the relationship between y and x, or x and y, you can say, right? So m and c is basically a trainable parameter. We try to train, and this is what we try to call as a linear regression, right? Training of the model. Now here in case of a convolution, this is the trainable parameter. This is what we try to train eventually. Fine. Okay, that's cool. So this is what we try to train. So how it is going to apply on top of the images and what I will be able to get as an output. Let's try to do a math for that, because many people technically get stuck only with this one. Yeah, only with this one. So here, what I will do, so I have this 3 cross 3 kernel, right? I can take 3 cross 3, I can take 5 cross 5, I can take 7 cross 7. That's completely fine, cool to all of us. So I'm going to take 3 cross 3, and what I will do, I'll try to apply this 3 cross 3 on top of this one, on top of this particular segment that I have highlighted over here, right? I have highlighted over here, and it is going to give me one single pixel. For example, right? For example, if I'm going to apply, right? If I'm going to apply this entire filter on top of this particular image, so it is going to do a calculation. What kind of a calculation? So this to this, this to this, this to this. So this calculation is going to happen in this particular manner. So 1 into 1, 1 plus this one, just focus on my pen. So 1 into 0 plus 1 into minus 1, 1 into minus 1 plus 0, right? So plus 0 into 1, 0 into 1 plus 1 into 0, 1 into 0 plus 1 into minus 1, 1 into minus 1 plus 0 into 1, 0 into 1 plus 0 into 0 plus minus 1, sorry, 1 into minus 1, 1 into minus 1. Now this is going to give me some sort of a value. Yeah, this is going to give me some sort of a value. So if you are going to do a calculation, so it is going to give you minus 3. Now this is my new pixel which I will be writing. So this is going to be minus 3, right? Okay. Now, so here we are able to cover this particular segment. We are able to cover this particular segment. Now I'm going to take, so here we have a minus 3. We are able to cover this particular segment. Now we have to move a kernel. We have to slide a kernel. by how many unit? So maybe we can try to move it by 1 unit. Maybe we can try to move by 2 unit. Maybe we can try to move by 3 unit. So that movement is called as basically a stride, S-T-R-I-D-E, stride. So stride is what? The number of unit we are going to move horizontally or vertically. So here it's called as S-T-R-I-D-E, stride. So my stride, let's suppose I'm going to consider as a 1. So again, I'll try to apply a same filter, this particular filter on top of this image. And now I'll try to move by 1 step. So once I'm going to move my 1 step, so now you can try to focus on my yellow part. And now I will try to do a calculation once again. So 1 into 1. So this 1 into 1, then 1 into 0 plus 0 into minus 1 plus 1 into 1 plus 1 into 0, 1 into 0 plus 1 into minus 1, 1 into minus 1 plus 0 into 1, 0 into 1 plus 1 into 0, 1 into 0 plus 1 into minus 1, 1 into minus 1. Now, so again, it is going to give me a final result. So it is going to give me technically 0, by the way. If you are going to do a math over here, right? If you are going to do a math over here, it is going to give you a 0. So I'll try to put 0 over here. Now, again, what I will do, my strides is equal to 1. So again, I'll try to slide this particular filter by 1 step. So now I will be covering this particular one. Yeah, a red one, by the way. And I'll do the same thing exactly. So again, I will try to do 1 into 1 plus 0 into 0 plus 0 into minus 1 plus 1 into 1 plus 1 into 0 plus 0 into minus 1 plus 1 into 1 plus 1 into 0 plus 1 into minus 1. And then my outcome is going to be 2, by the way. My outcome is going to be 2. So I'm going to write 2 over here. Yeah, I'm going to write 2 over here. Now, again, I'll try to apply a filter. Now what? So in a horizontal direction, I don't have any other pixels left. I'm able to cover all the pixels. As simple as that, right? I'm able to cover all the pixels. So now I will try to move vertically down. So strides is equals to 1. So 1 step I'll try to move. And here, this blue region, which I'm going to mark. So this blue region. So now same thing we are going to perform with respect to the blue region. So we are going slow, but yeah, I think for the very first time, this is very much important. But after that, I don't think that you need this lecture once again. You don't have to even come and visit this lecture once again. It will be sorted, by the way. So here 0 into 1 plus 1 into 0 plus 1 into minus 1 plus 0 into 1 plus 0 into 0 plus 1 into minus 1 plus 0 into 1 plus 0 into 0 plus 1 into minus 1. Now this is going to give you a value is equals to minus 3. So I'm going to write minus 3 over here. Simple, right? Simple. Now, so after that, so again, I'll try to slide. I'll try to like slide this entire one in a horizontal direction, into a horizontal direction. So now I will be here. So this particular region, which I'm trying to mark as of now. Now, if you are going to do a math for this particular region, you will be able to find out a value is equals to minus 3. Then you are going to slide basically with this region, the marked one, and then you will be able to do the exact same thing. And you are going to get a value. So the previous one was minus 3. So next value you are going to get is equals to 2, I believe. But yeah, let me check once again. I have already taken a note of this entire calculation so that I won't have to do this calculation once again. So minus 3 and then 0, and then we have 2, then again minus 3, and then minus 3, and then 2. Okay, so 2. Now, so now I'm going to move my kernel again into a vertical direction, and I'll try to capture 3 cross 3. Again, I'll try to move horizontally. Again, I'll try to move horizontally. So in this way, I will end up covering the entire images, and then I will be able to form this entire matrix. So it's going to be minus 3, and yeah, so it's going to be minus 1, and it's going to be a 2. Maybe you can try to check the calculation if I have made any kind of a mistake, but yeah, this is how the calculation is going to happen. Now, this is nothing but, right? So this is nothing but it's called as a final output after doing a feature mapping. So we have mapped the feature, we have applied a kernel on top of these images, and finally we are going to get this particular image, and this particular step which I have discussed is called as convolution. This particular step is technically called as what? It's called as convolution. So we are able to apply some sort of a filter, and my filter was completely a random filter, right? My filter was completely a random filter, and this is something that we are going to train. These are the value which I'm going to change when. So in a backward propagation, so when I will try to learn the shape. Now what this feature is trying to signify. So let's suppose if I'm going to apply a multiple filter, not just this filter. So maybe I'm going to consider a 3x3 other filter. And if I'm going to apply, so maybe 0, 0, 1, 1, 1, 0, 2, 1, 2, something like this. If I'm going to apply some kind of this kind of a filter, if I'm going to apply. So this filter, right? This filter will try to identify some pattern. This filter will try to learn some other pattern. So in this way, we can try to apply a different kind of a filter on top of the images. Now coming back to my CNN explainer, by the way, and this is what you will be able to observe even over here. So let me start from the start, by the way. So here, let's suppose if I'm going to show you this part. So you will be able to find out that this filter is sliding, right? Just try to observe this. This filter is sliding on top of the images. And here is a kernel. So this is the kernel that I have, a 3x3 kernel, and it is trying to slide over the image, right? It is trying to slide over the image one by one, one by one. Again, look carefully. And then it is trying to extract some sort of a data. Now, again, it is trying to apply on top of the another layer, then another layer. And when we are going to combine all of these layers together, we are able to say that, okay, fine. So we have a convolution. So we have applied one filter, one kind of a filter, and then we are able to do a convolution. Then here, right? So we are going to apply a different kind of a filter, and you will be able to observe that every filter is trying to extract some different information, right? Every filter is trying to extract some different information. So all of these images that we are able to see after a convolution is not same. So some is trying to capture a deep line, some is trying to capture the holistic shape, some of this is trying to capture some of the spot inside the images. So every filter that we are trying to apply, so it is trying to learn a different kind of a feature out of the images. This is what a kernel does. This is what a kernel does. Now, if I'll talk about this entire thing, so here you will be able to find out that how many filters we have applied. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in total, there are 10 filters which has been applied on top of these images, and all of these 10 filters are trying to extract a different kind of information. You can even try to like a check over here. So you can try to check basically like what is the kernel that we are trying to apply on top of the images, and you will be able to find out the complete value out of it. Yeah, you will be able to find out the complete value out of it. So this is something called as convolution, guys. This is something called as convolution. So with the help of convolution, so we are trying to extract all the major feature from the images so that I will be able to use it, and I will be able to train my machine. I will be able to train my model in a backward propagation. I will keep on changing this filter. So the filter value that you are able to see over here. So this is something that we are going to change. This is not going to be same in a backward propagation. This is something called as training, and this is how convolution happens. So hope all of you are able to understand the meaning of the convolution. So how we are able to produce this image. So we have a 3 layer. So every layer is trying to do this. Every layer is trying to do this, right? Every layer is trying to do this. And then we are trying to perform the addition operation, a pixel wise addition operation. So we have 3 layers. So we are just trying to do a pixel. So whatever is available at 1 of 0, so just try to add it. So 1 of 1, add it. 1 of 2, add it. Simple, right? Or 0 of 0, add it. So we are trying to perform the pixel wise addition operation, and then eventually we are able to form this one. In between, so yes, we are trying to add some of the errors, some of the biases, so that, I will be able to learn something more out of it, the way we try to, add a C inside y is equal to mx plus c in the exact similar manner, nothing much. But here, so this is how we are trying to extract a different kind of information, and throughout this entire layer, so wherever you will be able to see a convolution, right? So wherever you will be able to see the convolution, so everywhere you will be able to find out that we are trying to identify, or we are trying to extract a different kind of a feature, because these are the feature which is responsible for this entire images. And finally it will be able to do a classification, right? Finally it will be able to do the classification. So once it is going to, or once it will be able to, let me go up, yeah. So once it will be able to learn each and everything, then only it will be able to predict that, okay, fine, so this is the image of this one or that one, as simple as that. Okay, so hope this calculation is completely fine. In an upcoming lecture, so I'm going to talk something more with respect to the convolution. For example, a pooling layer we try to add. Strides I have already discussed with respect to this one. Then I'm going to even discuss what is a padding that we try to do. So pooling, padding, each and everything we are going to cover in my upcoming lecture. So with that, thank you so much everyone. Take care and see you again in my next lecture.